Hello calculus students and seekers of general truths. In this video here, we will talk about and study definite integrals. And there's so much that we could say about definite integrals. So I want to narrow the scope a little bit. And in this lesson, we're going to have three goals. First is to define, interpret, and apply the definite integral. Big emphasis here on apply. Then we'll compute simple integrals. And simple is, I realize it's a relative term, but the simplest ones without a calculator at all. And then for the more complicated ones, we will use a calculator. Now, a little bit later in the course, we will calculate with even the complicated ones without a calculator. Okay, but for now, we get to use our calculator for the problems that are a little too complicated. Alright, so let us talk about the definition of the definite integral. Is the area between a function f of x and the x-axis. So let's say that I in fact have a graph of a function f of x that looks something like this. So here is the xy plane. Alright, and then I graph f of x, and let's say, just for the sake of the argument, that f of x looks something like the following. So let's say it goes up and down and up like this, a little sinusoidal-like in nature. And we're going to say this expression right here, this weird symbol here, is called the definite integral from a to b, where a and b are some numbers. So let's say from let's say a is here, and then let's say b is like right here. Right? And then what we're talking about here is the area between the curve of f of x and the x-axis. Okay, so this notation is a shorthand way of describing this area here. And you can see that this area, when we have a curve, it's a significantly more difficult problem than what you may have learned in geometry. All right, and then one more thing: if f of x is less than 0, then the definite integral is negative. So if we have this area up here, and let's say this area is equal to 5, then this definite integral is equal to 5. However, if we were to integrate between these two x-intercepts, then the definite integral here would be a negative number. So this is the negative of an area. Okay. It's not the negative area. Area is always positive. This is the negative of the area. And we will look at many different contexts throughout the year, starting with the next video here, as to what is the meaning exactly of negative of the area. But hopefully what you take away from this video is the meaning of the definite integral. This algebraic notation here describes the area between two particular points on an xy plane.